Alright, mentally math! Let's get mental! Alright. Focus on this for the moment. Let you get out a little bit ahead of me. Keep it professional, please. Okay, so just giving you a moment to get ahead of me. Why aren't you starting? Okay, please. Go. Had plenty of time to get ready.
They made E exponent this
Mm.
time. No.
No estimation today.
Yeah.
Oh, that's always so much fun. Watch people get all bamboozled. Yeah. Oh well. Okay, so I'm sure people are a couple out ahead of me at this point. So I'm looking at this like $4.20 plus 30 cents is $4.50. Then the decimal's exponent, so this is divided by 100, so 2 boingies to the left, boingy, boingy. So it's gonna be 45 thousandths. And looking at this, I can think 90 divided by 5 is what I see there with the cross multiplicative goodness, and then dividing by 5. Yeah. So oh yeah, there are so many different ways to do this.
15 files and 5 is equal to 3.
Right.
Exactly. 3 is equal to 8.
That's what most people in last class did. Yes, was to reduce the 5/15ths and then use that to work from.
15.
Uh-huh.
I just
Sure.
noticed that the
No problem.
numerator is 3 times the denominator.
Yeah, totally. Very nice. Alright, converting. Oh, isn't it so simple to convert metrics?
Yeah,
So just divide it by 100. There are 100 centis in a meter. So
what's up with the imperial system? Why do people use it?
Most people in the world don't.
And why is that even called the
Basically America. Well, because it was part of the British Empire. I guess the way you'll see that said now is more like they say the conventional system, but the only place it's really conventional is the United States and a couple of very other random countries in the world. So it's not very conventional either. So I don't know, just America doesn't seem to want to change. So that seems sad. Alright, 1,000 minus 400 is what I'm seeing here. Yeah, we'd all be better off if America changed over to the metric system, yes. Okay, then, this I'm just looking at just 200 minus 20. And then how many different ways can you arrange the digits? Oh, I love this little shortcut. 1 times 2 times 3 times 4. But yeah, of course that doesn't do anything.
Mr. Crutchery, I just did 2 times 3 times 4.
Yes, but a way to remember it is it's just you do one multiplicative jump for every digit to arrange. Yes. Oh well, you may able. Oh, way too much work! Whoa! Yeah. Oh no, because this is mental math. you didn't need to do them all out. Definitely, you can just do that one weird trick we've got here.
Wait, how's it times 2?
Huh? Well, basically the way to remember it, I'm including the one. I'm including the one as just a memory trick. You know, just to remember that it's just one multiplicative jump for every digit that you're arranging. But of course, this doesn't do anything, so you know. But it's just to help remember it. Remember the trick. Okay, and at 80 kilometers an hour, how far will it drive in 2.5 hours? Well, 160 plus 40 is 200 kilometers. You're gonna be disappointed if you don't get black hole, aren't you? Okay. Oh, they're actually a lot easier to see actually on the iPad.
Yeah. Ooh, cool. Oh,
Right.
That's space.
It does look very spacey.
Are there supposed to be stars?
I don't know. I think yeah. I'm not sure the reason for that. Okay.
Can I get my glasses off?
All right. So we're doing order of operation. Please excuse my dear Aunt Sally. What was one of the monkeys?
Purple monkeys dance and sing.
Purple monkeys dance and sing.
That excludes exponents.
Huh?
That excludes exponents.
Oh, you shouldn't exclude the exponents. Yeah. So please.
People eating monkeys are silly.
People eating
Eating monkeys. I need a D.
People eating monkeys.
Or silly dogs.
Okay, anyway, not important. We can just remember, please excuse my dear Aunt Sally. Alright, so, if we're looking at this, you know, we can think that there are imaginary parentheses on the division and multiplication. I bet this will take you about a minute to do it faster than me.
I did this on Matthew yesterday.
Yeah,
I did this on Matthew yesterday.
Oh, okay.
Mr. Patrick?
Yo.
So, do you want us to, like, show each step of how we simplify it? Or is it
Good idea.
That's what I did.
Sure.
Or is it okay if we just write the number again?
I think showing your steps is good. I'm going to show my steps. Okay, so 2 plus 12 minus 2. 12.
Yeah, I started with 2 plus 12 minus 2, and then I decided to squish it. Wait, can you go back? I just want to copy it.
What? Copy it? Why would you need to copy it?
I mean, write it down.
Oh, okay. Well, just the problem itself. Okay.
I know the answer, but I didn't.
Right. Okay. And yeah, stop me if I'm going a little too fast because I will want to go fast through this because it's pretty simple. Okay. Huh? Oh, you shouldn't, because okay. So doing out all the steps. So.
2 plus 4 equals 6 times 3.
So think that there's, you know, you do the multiplication and division before you do any of the addition and subtraction. So that ends up there. So 4 times 3 is 12.
Because if you do that, you get 7. Because 2 plus 4 is 6 times 3 is 18 minus 4 is 14 divided by 2.
Yeah, and well, this is almost a little cross-canceling goodness going on there. Yeah. Okay, so you understand why it was incorrect? Okay, nose. Right. All right. So please excuse hint, my dear Aunt Sally. See if you can do this faster than me. It shouldn't be too hard. Can I just give you a new pencil?
No, it's fine.
Okay. So are you finished? You getting started there, buddy?
Yeah, I'm finished.
Okay, so we would do exponents first. So parentheses, exponents, no parentheses, but we got our exponent. And then next we do the multiplication. Then we want to solve what's on top. That's a thing. And yes, today's lesson was brought to you by the number 12.
Again?
Yes!
Multiply it instead of dividing it.
Uh-huh.
I'm multiplying.
What?
Dividing.
Okay, well, don't multiply instead of dividing it. That will not get you a correct answer.
I feel like you should be on the mental one.
Oh, I know. It doesn't get much harder either. Okay, so evaluating this. First you plug in the numbers. Okay, so you can get it done quickly and be on your merry way to doing some other sort of classwork. So yeah, we can be finished with this in like a few minutes. There's only one more. But it's not that much trickier than this. So
This thing isn't even tricky.
I know. There were much harder ones on the test you just took, and okay. Oh, are you feeling insulted? Well, I guess that's good though that you feel insulted because that means you know this. That's great. Okay. So first we plug these in.
I just put 3 times 4. Is that fine?
Sure.
Wait. How come our book says 2? Yeah.
Okay.
Our book says course 2 on it.
That's not important right now. Okay, and so I can see that 3 plus 12 equals 15. All right, now try this one. Yeah, it's not that much harder than the previous one. Okay, so get it done quickly, and then you can get on to doing your classwork and get on to doing some other things. Work on your drawings.
Do you mind if I did some random questions from lesson 67 that my dad asked me to do?
I'm not stopping you from doing that, I guess. Okay. Alright, so that should have given you time to plug in these numbers. So we'd say 9 times 2/3 minus 9 halves. Okay, so for starters, I can put my imaginary /1 under there. Do a little cross-cancel-y goodness. It doesn't matter as long as if your way will get you to the correct answer and it makes sense to you and would work for any problem. See, I think while I'm at it, I'm gonna do this part too. That's 4 1/2. And then for this, I mean, it is kind of mentally mathy, but just for reference. Oh, well, don't do that because this is presented in the form of a fraction. And that's presented as a fraction. So at this point, doing a decimals, you're kind of jumping the shark, is it? Where? Oh, I think I just dated myself with that reference. Okay, and I know you could probably do it with mental math, but one thing we could get a little quick moment of review with is if we've got something like this and there's nothing to subtract from, then we can do a little borrowing. And so what I can do is I can take 1 from here and put it over here, right?
5, 1, 6.
Okay, well, why don't you take a look at how this was done then, because the answer is definitely not 5 and 1 6.
Oh, I just.
So now are you realizing that you are adding, subtracting, not multiplying fractions? So when you do that, you don't do anything with the bottom number. Right, you don't do anything with the denominator. Okay, so basically I've taken 1 from my whole numbers here, and I'm presenting it over here as 2 halves. And so that way I have something to subtract by 1/2 from. And then 5 minus 4 is 1, getting us da-da! Okay, so do you understand where you might have
I started converting the fraction to have the same lesson, the denominator.
Oh, okay, but well, you didn't need to do that over here because it came out to just be 6. So you didn't have any denominator there. So you would do this as its own. You do this as its own thing first, and this is its own thing, and you're.
I got confused.
Oh, okay. Well, that's what we're here for, to be checking ourselves on that. Okay, and that's today's lesson, people.
That's it.
I know.
But can we copy down the order of operation thingy?